Welcome to this video. In this video we will see hardening methods, which is also called as diffusion treatment. So diffusion treatment is done to add certain elements like carbon and nitrogen in the surface of steel to make the surface hard. So what happens is carbon and nitrogen takes place the voids and interstitial space. So these elements carbon and nitrogen get diffused in the voids and interstitial space and resist the motion of dislocation. So interstitial space between the atoms and the voids, like substitutional also, it will take place iron atom, and there will be substitutional vacancy, substitutional defect, and carbon and nitrogen is introduced inside the material. So what happens is they will resist the motion of dislocation. For motion of dislocation, the grain size should be perfect and it should be bigger. But if there are certain elements like carbon nitrogen in between, the dislocation motion will be resisted by that, and the material will get harder because we have to apply more load to have dislocation motion. The first method is nitriding. So in nitriding we take an airtight atmosphere and NH3 is passed over the steel continuously, and at 600 degrees Celsius this process takes place. So what happens is nitrogen atom is diffused inside the surface of the steel, and main advantages are hardness increases more than carburizing. In carburizing we add carbon, in nitriding we add nitrogen by ammonia gas. So hardness is increased, and corrosion resistance and wear resistance, endurance limit, every this property are also increased. The disadvantage is it is very costly and the surface becomes brittle. In cyaniding, the steel workpiece is immersed in a molten salt bath containing NaCl. So NaCl molten salt bath is there. We have to immerse our workpiece at 850 degrees Celsius, and we have to immediately follow it by water quenching, so the surface will get harder because of the water quenching. And this cyaniding process is less time consuming and less distortion takes place. High corrosion and wear resistant surface is obtained. Its disadvantages are it is very costly and NaCl is a toxic, so there is a hazard of health. In carbonitriding we introduce carbon and nitrogen atom both. So in carbonitriding, heating the steel with ammonia gas and propane gas, and both carbon and nitrogen diffuses in the surface. So here carbon and nitrogen both will resist the deformation, resist the dislocation motion, which will resist the deformation. So in flame hardening, the flame is there, means the flame of gas is there at 2400 degrees Celsius and above, and we have to heat the surface by the temperature, and then we have to cool it in air or water. So after cooling it, grain will be very fine and there will be very hard surface obtained. In this process there is no distortion, surface remains clean as there is no other chemical in other process, and it is very easy and can be automated. It is very efficient process also. And disadvantage is it is not possible for thin surfaces, because thin surfaces at this much temperature will easily get distorted, or it will get a thorough hole inside it, and overheating can also causes a crack. So these are the disadvantages. In induction hardening, what happens is steel is placed into the helical coils called inductors, and coils are of water cooled copper tubes. So in copper tubes there will be current, which is AC current. So due to AC current there will be magnetic induction, and inside our workpiece there will be eddies of current. So these eddies of current will generate lot of heat inside our workpiece. So what happens is due to that heat, the material get heated, and then we have to quench material into the oil bath. So again there will be grain refinement, and grains will be much smaller and fine. This process takes less time and it's highly productive, and automation can be done, low distortion of the workpiece, and no scaling on the surface happens. And its disadvantage is we have to have a very good fixture to hold the workpiece, because there will be AC current inside it, so we cannot do it manually or by any other metallic object. So we have to have a fixture proper fixture to hold the workpiece. In carburizing, heating the steel with charcoal, CO2 or carbon monoxide to increase the carbon content of the surface. So here these three elements, any of one which we can pick, and we have to heat it in those environment, and due to that there will be C carbon diffusion on the surface. And advantages increase in ductility, toughness, hardness and strength, because ductility remains inside the material, toughness is also remains, and on the surface there will be hardness and brittleness on the surface, and it will have very good strength also, because both of these properties are present. And in carburizing, it is fire hazard is also there, and it is toxic because of carbon monoxide gas, and there can be fire hazard which is has to be prevented, and other safety measures are also need to be taken. So it is a little bit expensive, and equipment for this material handling are also expensive. So these are the various methods by which we can do surface hardening, and by this lecture we will come we have finished our heat treatment processes. In the next lecture we will see TTD diagram and other diagrams which are necessary for various competitive exams, and will give you more understanding in these topics. See you in the next video. Thank you guys.